to solve for sides and angles. I didn't want to take the time to show you using the law of cosines to solve for angles because I think in a 10 to 20 minute little video lesson, it's not going to make enough sense. So we're just going to skip that. But I've got an example here where you've got two known sides of a triangle and you've got one angle. So your reaction should be to say, okay, I'd love to use SOHCAHTOA, but why can't you use just straight sine, cosine, and tangent here?
It's not a right triangle.
Not a right triangle, exactly. Good. So the next thing you should be thinking is, cool, can I use
Of sines.
law of sines? All right, great. Can we use law of sines here?
No.
We can't. And the reason why is because I've got a 41-degree angle and I don't know the side across from it. Great. But what about those 14 and 17? You also don't know. Lando's the only one mic'd up here. You guys are all being bashful, but so go ahead, Lando. You think you know?
Jason, wait.
Why can't I use law of sines? What's it have to do with the 14 and 17?
Because you can't find the opposite side using the angle and adjacent.
This has been a rough semester for us. Okay.
Is it just because there's no angle across from it?
Exactly, dude. There it is, Jack. You don't know the angle across from 14, and you don't know the angle across from 17. So therefore, I can't use law of sines here. And that's why in the lesson that I showed you guys this week, we want to try to use our third tool, which is called the law of cosines, okay? So in this situation, I mean, I don't have any A's, B's, and C's and all that, but we don't need to do that. Your reaction should just be, once you figure out that you have to use the law of sines, you'll first go to saying x squared equals the two sides I do know. Let's see here. Two sides we do know, 14 and 17 squared minus 2 times 14 times 17 cosine of 41. The hardest thing about the law of cosines is that it's intimidating. That's it, okay? In one step, how do you go from x squared to x, everybody? You just take square root of everything. Exactly. Try typing this in on your calculators. I'll go put this down and whale on my calculator. And sometimes I'll do it in 2 steps on my calculator. Example, it might be tough to see with the light here. That's just blocking it. But if you just type in 14 squared plus 17 squared minus 2 times 14 times 17 cosine of 41, we'll get some pretty big number here, right? But then you can just take the square root of your previous answer. So you don't have too much going on in one step. It just sort of breaks it down a little bit. Guys, I'm getting 11.21, it looks like. Lost my marker. Okay. So going back, looking at the sides in our answer, okay, we got the shortest side and it's across from a 41-degree angle. Most likely, if your one known angle in a triangle is 41, the other two have to add up to 139. So they're probably going to be both bigger angles than 41. So we should feel good about our answer is what I'm saying. Let's go back. Let's go back and do some just straight sine, cosine, and tangent. It's been a while since you guys have worked on that with me. Some people have been asking about it. I need to go grab an eraser real quick. But we're going to do some SOHCAHTOA stuff, okay? All right. What's up, Lydia? What else we got? We had Zoe for a second. All right, guys, I've got 3 sine, cosine, and tangent problems for us to do. How about I do the first one with you, and then I'll have you guys do the next 2. Cool? How's the timing on the sound? Is my connection a little better this time, maybe than in the past? Right on. And my comment about learning the stuff, guys, I can't imagine trying to learn it in the manner in which you guys are trying. So kudos to you guys for making the most of this. I love that there's 10 of you guys that joined me this morning for this call. So that's awesome. I'm going to do just this first one here. So if we're doing sine, cosine, and tangent, it's sometimes good to look at the triangle and label the sides that you've got. If you're at 63 degrees, this is my adjacent side. This is my opposite side. And this is my hypotenuse. However, I've got nothing down here for the adjacent. I don't know the length of it. I'm not trying to find the length of it. So I tell you what, I'm just going to ignore adjacent and delete that. So it's sometimes good if you're doing right triangle trig to have at the top of your page, just as a reminder, so ka toa. Okay. And if you can remember those 4 syllables, so ka toa, you can always remember what sine, cosine, and tangent are. So is spelled S-O-H. Sine equals opposite over hypotenuse. Ka is CAH. So that means that cosine equals adjacent over hypotenuse. TOA stands for tangent equals opposite over adjacent. All right. So looking at this triangle here, I've got opposite and hypotenuse. So I'm trying to figure out, okay, does that mean I'm using sine, cosine, or tangent? Which one of these three has O and H in it? So,
Sine.
right? So that means we're going to first just say that sine of theta equals opposite over hypotenuse. But now let's plug into this little equation here. Let's plug in everything that we know. Remember, theta is just a fancy way of saying the angle. So sine of 63 equals x over 14. In one little algebra move, I can solve for x by multiplying both sides by 14. Is that too far away there? So x just equals 14 sine 63. And depending on your calculator, type in 14 sine 63. If you've got a slightly less sophisticated calculator, you might just have to go backwards and do 63, then hit the sine button, and then do times 14. Okay? If you guys have calculator issues, please, 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 maybe stay on after this and we can address those. All right? So I'm going to type that in. But I'm expecting something in the neighborhood of 10 or so, I would imagine. Let's see, 14 sine 63. I was off. 12.47 is what I got. Cool? So far, so good? Okay, I'll even do this one with you guys. So I'm looking at my triangle. I'm gonna switch up colors here. Actually, that blue is probably good for you guys to see. If you're at 71, here's my opposite side, but there's nothing labeled here, so I don't care about my opposite side. Here's 4, so that's the adjacent side because it's next to 71. And here's x, the hypotenuse. So now we're thinking, okay, this one is involving adjacent and hypotenuse. Adjacent and hypotenuse. Which one of these three uses adjacent
Cosine.
and hypotenuse? What do you guys think?
Cosine.
Yeah, cosine. So we're going to say cosine of 71 equals 4 over x. Now going back to the lesson, I gave you guys kind of a slick move to do here. Whenever x is on the bottom of this situation, you can just switch it with the left side and leave 4 right where it is. Do you remember that from that lesson? Hopefully. So I'm going to say that x equals 4 over cosine of 71. Again, most of these calculators can actually handle that in one move. So go ahead and try to type in 4 over cosine 71. We're expecting something bigger than 4 because x is the hypotenuse and the hypotenuse is always the longest. So I'll type that in. I'm going to go with a guess of 9, but we'll see. Again, way off. I got 12.29, my friends. How'd you guys do? I've got a thumbs up there. .29. This third one. Why don't you guys go ahead and see if you can do that one on your own? So at this stage, and here's the nice thing. Normally, guys, we'd be able to practice this in my classroom, and I would get you guys so good at sine, cosine, and tangent. It would be the easiest thing you've done all year. In this situation, we've got, it's just plain harder to learn. So keep losing my green marker. But your mindset should be going into this one is to say, okay, let's see, x is opposite, 10 is adjacent, so I know I'm using tan. I've also got an angle that's just a little bit less than 45 degrees, which means my opposite side should be a little bit less than 10, okay? So you know going into it, you should be getting something that's 9 and change, or 8 and change. First, I'm gonna label these sides. Opposite. Adjacent. No need for the hypotenuse. So opposite and adjacent tells me I'm using tangent. So I set it up as tan of 41 equals x over 10. One simple little step to get rid of the 10 and get x by itself is to multiply both sides by 10 times 10 times 10. The 10s cancel. X is just going to be 10 tan 43. Type that into the calculator. Like we expected, about 9.33 I'm getting. So I'll hold that up here. Next thing I want to do, we'll do some more review, but let me take a second here to kind of summarize what's going on for the rest of the year, okay? Because that sort of changed for me on Monday, and I adjusted my calendar, but maybe you didn't see the calendar. Good news for everyone. I can't give you finals, all right? So you don't have a final, okay? The only thing you're gonna do is a test on all this stuff that we've been working on. Sine, cosine, tangent, law of sines, law of cosines, maybe some word problems. I'll send out a test for that. It's on the calendar like sometime May 18th or something like that. And you'll have until about the end of the year to get that test finished. Okay? You'll resubmit that to me. Hopefully you just destroy all aspects of the test. And your grade at this point can really do nothing except go up the more work you guys keep putting in, okay? So let's do a couple law of sines problems, and then we'll go back and do an inverse SOHCAHTOA where we're solving for an angle, okay? Just kind of make one generic triangle here. Okay. So I hold up my triangle, I look at it, and I see that I've got a couple sides to work with and a couple angles. I can't use the law of, or sorry, I can't use SOHCAHTOA because it's not a
Right angle or triangle, sorry.
Right triangle, exactly. Right? So the next thing we want to use is law of sines. Well, in this case, because I know a couple of the angles, we can use the law of sines for sure. So I'll set that up. And I'm solving for a side. So typically what that looks like before we start plugging things in is a side over sine of the angle across from that side. I get the right angle. Equals another side over sine of the angle across from that. What's the side we're trying to figure out? X. So that's what I want to start with. X over sine of the angle across from X equals my other side and angle combination. So 11 over sine of 37. What's today, the 7th? So again, I think next week, we're just going to be doing a bunch of review, and I'll be happy to answer tons more questions, guys, next week. So keep working at this stuff, and if questions come up, start them or something, and make sure to ask them next week. The nice thing about the law of sines is it just takes one step to get x by itself. I just have to multiply both sides by the thing underneath that. So sine 99, sine 99, and these cancel, and that's what x is. So I'll write it again a little bigger here. There's our final answer there. And I can type that in one step on the calculator. Be careful with your parentheses. Okay, if you're getting an answer that's way off, usually that means in trigonometry, you're either in the wrong mode or that you just haven't put the parentheses in the right place. Okay, so I'm going to go ahead and type this in. I've got 11 sine 99 over sine of 37. And it looks like I'm getting 18.05. How'd you guys do with that?
Good.
Same thing, just like the SOHCAHTOA stuff, you can go back and say, okay, does my answer make sense? Well, let's see. 11 is across from an angle that's 37 degrees. X is across from an angle that's 99. In other words, much better, much bigger than 37 degrees. So I should expect a distance that's a bit longer than 11. So we should feel pretty good about our answer. And sometimes people are like, all right, well, what if this was 33? Then I would know that X is 3 times as long as 11. Okay. The size of the angles and sides just tell us that X has to be bigger than 11 because it's across from an angle that's bigger than 37. I'm going to essentially erase the X's and the numbers and have you guys do one. Cool? I'm going to throw a curveball at you, but it's a hanging curve, okay? It's one that you'll see coming. Sorry for the excessive baseball analogies. Oh, what friendly numbers. Man, your teacher's nice. All right. Law of sines. See if you can do it. All right, so I'm going to start setting this up. It's one where we're solving for a side. All right, I'm going to start by saying that x is the side I want, so x goes on top. And then you might be saying, well, shoot, I don't know the angle there. But you guys are smart. Like I said, it's a hanging curveball. You know this angle has to be 80 degrees, right? So I can say x over sine of 80 equals my other combo that I do know. 7 over sine of 40. One step gets x by itself. Sine 80, and the sine 80 disappears. X just equals 7 sine 80 over sine of 40. Another good thing to think. Okay, 7's across from 40 degrees, x is across from 80 degrees. Doesn't mean x is going to be twice as big, it's going to be bigger than 7. Right? So let's type that in here. 7 sine 80 over sine of 40. I'm getting 10.72.
Yeah.
How are we feeling about that? All right. I'll set up 3 more here. Maybe this will tie it together a little bit. Okay. So here's one where I don't know if it's a right triangle or not, but I do know that I have to figure out an angle, and I can't use inverse SOHCAHTOA, but I can use the inverse law of sines to solve for x. Because I'm solving for an angle here, I'm going to say sine of x over the side across from x equals sine of 40 over the side across from 40. Now, the nice thing about this one is I know, okay, 5's a little bit bigger than 4, which means 40 degrees should be a little bit bigger than x is in. So again, in one step, I can get sine of x by itself by multiplying both sides by 4 there. But we still have a little work to do. I know that sine of x equals 4 sine 40 over 5. So x is just the inverse sine of this whole expression. Again, it's kind of a nasty thing when you look at it to type that into the calculator correctly. So if you don't get the right answer, if your calculator is telling you something like a domain here, it probably means you just have a parenthesis issue going. So I'm going to hit on my calculator. Second sine, that's how you get this inverse symbol. It's usually just a shift or second on the calculator. And then on your numerator needs to be 4 sine 40, close the parentheses, over 5. So I'm going to type that in. Again, I should expect something just a little less than 40 degrees. Man, the suspense is just eating me up here. 4 sine 40 over 5. Just like we thought, 30.95 degrees is what I got. Okay. So the nice thing, if we've got a right triangle, is this inverse stuff is actually a little bit cleaner and simpler. I'll give you guys 2 triangles that are right triangles with missing angles. See if you can use inverse trig to solve them, and we'll call it a day. Okay? And then those of you that are having calculator issues can stay on and we can talk about that. All right, one sec. Oh, same numbers, different answers. See if you can handle this. Oops. One sec, one sec. All right. Now it's legit. You want to be looking for those right angle symbols to be sure that it's the right triangle. We don't want to assume. So I'm sure you didn't, but if you're using the same inverse trig function, then you haven't quite set it up right. All right. Let me erase my other stuff so it's not confusing us too much. So I'll do this first one on the left here. If you're at theta, 7's the opposite, 10's the hypotenuse. SOHCAHTOA means, okay, opposite hypotenuse, I gotta start with sine. So sine of theta equals 7 over 10. We want to figure out what theta is, so it's going to be the inverse sine of 7 over 10. So second sine, 7 over 10, I'm guessing, man, somewhere in the neighborhood of 60 something, but we'll see.
You're a bit off.
I'm off? What? Yeah, right. Ah, touche. 44.43 degrees. See, you can tell I'm distance teaching as well. My estimates have just been terrible today. Next one. Label our sides. Here, 7 is the opposite still. A 10 is at the hypotenuse. It's the adjacent. So that means I'm going to need to use tangent. Tan theta equals opposite over adjacent. Plug in what we know. We don't know tan. Sorry, I don't know theta. But I do know that the opposite is 7. and the adjacent is 10, and it's a right triangle. So tan inverse of 0.7, or 7 over 10. This one, we know it's going to be under 45 degrees. I'm going 38 and change. Let's see. How'd I do that time, Lando? Better?
You're a bit off still.
34.99. A little better. Okay. So, to recap some things here. No final. The test on topic 8 is the end of the year, okay? Which means also, law of cosines was the last new thing you're learning this year. So all we're looking to do to make sure that you understand SOHCAHTOA, law of sines, law of cosines, and then maybe how to use them in some of those trickier problem situations that the book throws at you. And that's it. That's our year. So our finish line, the light at the end of the tunnel, however we want to think of it, is there, guys. We're almost there, okay? 3 weeks from tomorrow, it's done. So hell yeah is what you should be thinking. I'll let you guys head out of here. Thanks for joining and working hard through those questions. I hope that clarifies things a lot and you feel like you've got things understood. If you got a quick question now, talk to me.
I got a question. Just with the topic 6 and 7 tests you sent back out,
Yeah.
do you have like a due date on when you want those back in?
That's a good one. I didn't really give you guys a due date on that. Just make grading a little bit easier so I'm not dealing with that at the same time as the topic 8 test. Maybe a week from tomorrow. And I'll send out a communication on that so you're not just getting it from me telling you here, but try to get, and you just have to pick, and I think this was clear, but one standard from each of those tests based on your Power School grade that you'd like to improve. Okay. Some people are saying, do I have to? And no, if you feel like you're happy with your grade or you don't want to do that, you don't have to. But it's an opportunity that I think you guys should take advantage of because we haven't had a ton of grades this semester. And I am going to try to be as giving you guys the benefit of the doubt with everything as far as grading goes. Take advantage of these chances. They'll bump your grade up. If you guys have a calculator issue, go ahead and stay on. Otherwise, thanks for joining in. Keep working hard, and we're going to get through this.
Mr. Sunderland?
Yes, sir.
So there's the law of sines and the law of cosines. Is there a law of tangents?
You know, you are not the first person to ask that. That's a great question, dude. There is not yet until maybe you can come up with one.
But would you need to? Because once you can solve for the law of cosines, then you can just switch it over because you have what you need to work with for the law of sines to find any other angles or sides.
Nice. Someone watched the video, didn't they? So exactly. Yeah. Typically, if we've got some like weird amorphous triangle, it's not amorphous. It is a triangle. But if we've got a scalene triangle and we're piecing it together, you're right, man. Once you use the law of cosines to either get an angle or a side, you can use the law of sines to kind of take you from there. But as you guys will figure out, not this year, but a year later, once you get into pre-calc, there's all sorts of crazy stuff we start doing with sine, cosine, and tangent. That's some of the most fun math you'll do. Some of you might be cringing and you're like, there's no such thing as fun math, but not true. Sweet.
And then also on the law of cosines, do you have any advice? Like when you use it enough, you start to memorize it, and you can kind of find the inverse of the law of cosines by just having the law of cosines. But
yeah, so the inverse of it's a little nuts. If you can picture a
No.
squared equals b squared plus c squared minus 2bc cosine of a, the inverse essentially means that a is the inverse cosine of all that stuff after you algebraically undo it.
yeah,
Uh,
the inverse, like I have it, but what I guess is, should you memorize, you'll end up remembering the law of cosines just by doing it enough, like you said, but should you try to memorize the other, or should you just solve for it when you need it?
Nah, the latter. I don't know what the inverse law of cosines is, and to be honest, man, it's not. A law of cosines isn't something you do a ton of outside of geometry. Whereas the law of sines and right triangle trig, those will start, especially right triangle trig will come up a bunch in physics, and more advanced math will hit on some of the other trigonometry stuff. Law of cosines is sort of one of those last option things when you're trying to solve for a triangle. Doesn't come up a ton. It's pretty easy to memorize the law of cosines because it's sort of like the Pythagorean theorem. And the two sides you do know are like, say, a squared equals b squared plus c squared minus 2 times those sides, cosine of the angle across from whatever's on the left. The law of cosines isn't too hard to remember. The inverse one is just something that doesn't come up enough for you to feel like you need to memorize it. And I wouldn't ever make you guys memorize either of those. So.
All right, thank you.
Yeah.
All right, thanks, Mr. Sunderland.
You got it. Peace. Anyone with calculator questions, stick around.
Thank you.
You got it.
Thank you.
You guys are very welcome.
Thank you.
My pleasure. Gavin, you got a calculator thing?